So I think this kind of is bringing us up to our mountaintop, and this is the key to being able to get past blockers is iteration. So one phrase that I coined recently that still doesn't really make sense, but I makes sense to me is iteration is the currency of learning. So if you're trying to get people who can learn rapidly, learn faster than the competition is learning, then they have to be running tight iteration. And so I think setting an expectation with that team and developing a culture where those quick iterations are happening is the most critical thing you can do. It is not to have the perfect plan. The perfect plan will never survive contact with with the opposing force, right? What is instead the best thing to do is to set an expectation and begin developing a culture of quick iterations. I've seen a lot of this recently as we've gone through. I've gone through a lot of these transformations personally, where it's great. A consultant can come in and tell you, here's all the best practices in the world, and developing a race car in this example or whatever, developing software and developing HR practices, whatever you're doing. But really, those things are great only up until a point. Only up until, are we actually iterating? Are we actually
Right.
learning? So let's wind our way up to our mountaintop here and talk about a concrete example in Ford versus Ferrari of those quick iterations and learning. Brian, do you want to talk about this moment for us?
I do, but I want to set it up. I want to put a little bit more concrete around what you just said because I love this. This movie, this analogy, right? Driving a lap around a racetrack is an iteration, right? This is one. We did one cycle of the car did all the things that it was supposed to do. You have a very high level metric, which is lap time, right? The person with the stopwatch on the wall can tell you whether or not the iteration overall went better, like did the car get faster or not. The person with the stopwatch on the wall cannot tell you how the car felt. It cannot tell you how much power it made, how hot the tires got, whether or not it started to oversteer or understeer, like all of this stuff. And so what we see in this moment is Ken Miles, who is very, very deep into the process, right? He's very intuitive about driving cars. He's very skilled at driving cars. He's very skilled as a mechanic. He's driving this car around a couple laps around the racetrack. He's doing his iteration, and he comes back and he says, "There's air getting trapped into the hood. There's an aerodynamic problem that's causing us drag, which means we're not going as fast as we want to." And they're not seeing it in the data acquisition system that the Ford guys have brought in, and they're really skeptical. And they argue back and forth a little bit. And again, Carroll Shelby as our archetype of leader here, he's like, "All right, we're going to run the experiment. We're going to trust that your intuition is right, and we're going to what's the cheapest, quickest, dirtiest, stupidest thing we could do to check that." So they get a ball of yarn and they tape a bunch of string all over the car, and he goes and drives around the track again. They're standing there with their binoculars, and they're watching these pieces of string stand straight up at speed where the air is getting pushed out of the hood and getting trapped into the car and causing drag. And even the engineer, they ripped the data act out of the car, but even the engineer that was, running the acquisition system is like, "Oh yeah, look at that, he was right. The aerodynamics are messed up, right?" And so they've got a hypothesis. They figure out a really quick and dirty way to go just check the hypothesis. Does this make sense? Oh, this hypothesis does make sense. Well, now we're going to go do a bunch of hardcore engineering, right? We're going to go design a part. We're going to change the layout of something. We're going to change the shape of something. This is not just going to be solved with duct tape. But running that iteration with whatever sensors you can get into it that'll look exactly what you're going on, that's the mountaintop, right? Progress through whatever means is necessary by this quick iteration. Trust your experts, but then find a way to validate what they're saying. And once you think you know what's going on, fix that problem and move on to the next one.
Yep.
That is the soul of innovation with unknown constraints, unknown problems, but a known desired outcome.
And this is what you see oftentimes called like lean startup, right? When you run a lean startup, everything is just fast iterations, the quickest learning cycles that you possibly can get. You want to get feedback from the customer as often as possible. And so the old systems oftentimes end up assuming that they know what the customer needs. If we just get this metric right, it'll just make the customer happy. But assumedly in a transformation, there's unknown information and we need that information. The more of that information we can get earlier, the better. So running those early iterations, that buys us learnings, that buys us that information. So that example that you just illustrated is perfect. It's just a micro example of how they're applying it in racing. So how can you apply that in your business? How can you empower your teams to apply that level of quick iteration? I think one thing is, if you're a top leader, setting the expectation with the team that what will be rewarded is effort. What will be rewarded is learning, not necessarily documents and plans and all that kind of stuff. No, what I want to know is what works and what doesn't work, what satisfies the customer, what provides value, and how, is it feasible? Can we actually do it? Have we test driven if the model works for this? Have we test driven if this subsystem of the vehicle is going to allow us to achieve our overall goal of a certain lap time or a certain, ability to corner or whatever, right? That progress through iteration really is the key to developing that lean agile enterprise.
And I love, again, I love this example because it gives you the analogy, right? You still tie it back to lap time, right? Like it's great. Like we learned that the car has a drag problem. We went from intuition to sort of validated something great. Now we're going to run another experiment where we're going to change something and see if we can get the aerodynamics better. We didn't learn anything real until the car got faster. If the lap time goes down because you changed the aerodynamics, or because then you learn something, then you made progress. That's the kind of innovation that you're looking for. And so it's not to say that the high level metrics of customer value or sales numbers or website clicks or whatever aren't valuable. They totally are. That's your stopwatch. You need that, but that's not enough insight to decide how to make something better, right? So you need experts, you need intuition, and you need detailed observations of what's happening at the ground, on the track, rubber meeting the road, whatever analogy you like, right? That's what you need.